And the 1/2 is the square root function. So this is the same thing as putting 5x in a square root. And recall from yesterday, square roots are the ones typically because they're the first root that's introduced to you. We don't put a number here. If you want to put a little 2 there to remind you it's a square root, that's fine. But usually, like if I ask it, I'm not going to say, I'm not going to put the 2 there. Okay, does anyone remember what does a negative exponent mean? So today I'm going to write these down. We're going to hit that harder in the next few days, but a negative exponent means you're going to do 1 over. So the negative portion of this means this is the same as 1 over x z to the 4 over 3 power. That's all that negative part means. Okay, so when you see that today, that negative part, just make sure you take the reciprocal. All right, refresher from yesterday, and I actually am going to write it on our corner board so you don't have to keep flipping back and forth, is that if we have x to the 4 over 3, this bottom number is the root, so that makes it a cubed root, and this top number is what we're raising the exponent to. And you can see that you can put it right here if you want, or you can put it out of the symbol if you want, your choice. I'll just do it in general. In general, if I see something like this, the b becomes the root or the denominator, and this becomes the power. So if I'm doing xz to that, the only difference is that I put the whole thing underneath the radical. So this is the same thing as 1 over the cubed root of xz, and in this one you can either put a parentheses here to the 4th, or you can put it out here, but the whole thing does have to be raised to the 4th. Okay, so then let's talk about simplifying things under the radical and pulling things out. So I'm going to write some in-between work for some of these, and hope you might not have to. So you might see right away, hey, I know how to simplify the square root of this. Remember, for square root, we're looking for something times itself. So what I'm going to do is I'm going to rewrite this as, if it's an odd exponent, a to the 3rd, I am going to rewrite it as an even exponent, a squared times a. Do you all agree with me that a to the 3rd is a squared times a? You're going to see why I'm doing that in a second. The b to the 20th, isn't that an even exponent already? So I'm not going to rewrite it. Okay. What I'm going to do with those is then the things that I can simplify are the things that have a perfect square. Like, for instance, wouldn't we all agree a times a is a squared? So what's the square root of a squared? A. So I can simplify this part. I'm going to bring it out in front. That's just a. I cannot simplify the square root of a. That's going to stay in. Let's talk about b to the 20th. Isn't b squared times b squared b to the 20th? So what's the square root of b squared then? B to the 10th. So what was the only thing I couldn't simplify? This one, and if you want to use highlighters, you should use highlighters, okay? The only thing I couldn't simplify was this, so I'm going to leave it in as the square root of a. Okay, what about fourth roots? Well, for fourth roots, so square roots, they would have to be squares. For fourth roots, the only thing I could take out would be things that raised to the 4th would give me that. For instance, is there a fourth root of 25? No. Is there a third root, or is there a fourth root of a to the 3rd? No. I'm going to be able to do that, because the fourth root of b to the 4th is just going to be b, right? b times b times b times b would give me b to the 4th. And then I'm going to rewrite this c to the 7th, okay? So I am going to rewrite the problem. I'm going to leave it as b to the fourth. If I wrote this as c to the fourth, what would have to be this exponent to make that together make c to the seventh? You can show me with fingers if you want. So c to the fourth times c to the what would give me c to the seventh? Three. Thank you. All right. So here are the things I'm going to be able to take out. I can take out the b to the fourth, and I could take out the c to the fourth. Everything else would have to stay in because this is a fourth root. The fourth root of b to the fourth is b. The fourth root of c to the fourth is c, and I leave everything else underneath the radical. So 25, a to the third, c to the third. All right, back to a square root. Do we know the square root of 9? We do. Okay, we're going to be able to take that out. Square roots, they just have to be, I can take the square root of even powers. So I'm going to be able to take the square root of x to the 10th. What is it going to be? What do you think? All right, well, I'll leave it for you. Y to the 19th, is that an even exponent? No, so I'm going to rewrite that one. I'm going to rewrite this as y to the 18th times y. We hopefully agree that that makes y to the 19th, but that's going to let me take the y to the 18th out. Some of you who are getting this or picking this up, you might not need to do that middle step because you know, hey, I can take the even one out and I know what's left in my head. But some of you are going to need to. We can do this. We can do this, and we can do this. Let's do it. What's the square root of 9? 3. What's the square root of x to the 10th? X to the 5th. What's the square root of y to the 18th? Y to the 9th, thank you. And I can't simplify the square root of y, so that stays underneath the radical. So we're just practicing taking perfect squares out if we can. All right. Let's do D, and then that's probably all I'm gonna, like, that is the most complex I'll get with those things. We'll talk up, and then we'll move on to evaluating. This is just a 2. That just means there's a 2 already on the outside. Do you see there's nothing written in the little corner of the root? So what kind is it? What do you think, Taylor? There's nothing written there. Which one is it? Square root. Good. Okay. So I just need to make sure that I rewrite things as perfect squares or even powers. So I have 2. Okay. Ooh. What perfect square goes into 32? Because I don't know the square root of 32. 16. I'm going to rewrite that as 16 times 2. I'm going to rewrite the x to the 5th as x to the 4th times x. Y to the 4th is already an even power, so I'm going to leave it. And there's no way to rewrite z as any less power, so I'm also going to leave that. All right, I'm going to highlight the things that I can take out or out from underneath the square root. All right, so what's already on the outside? That 2. I do have to leave it there. So this 2 is already there. What's the square root of 16? 4. So I'm going to bring that out. The 2 is going to stay underneath. That's why I'm leaving it unhighlighted. The square root of x to the 4th is x squared. The square root of y to the 4th is y squared. And I just took all of the things outside of the radical that I can. The things that would stay in are 2 and an x, and a z. The only other simplification I could do is I could rewrite this as 8x squared y squared, but that has to stay underneath. Okay. At this point, we won't be doing E and F. So, what do I mean by evaluate without a calculator? I guess if you wanted to pull this off, you can, if it's easier instead of flipping back and forth, okay? But what I have on this list are some things that are square roots, cube roots, fourth roots, fifth roots. Some of them you might know in your head. Some of them I think will become familiar after today. Okay, so that's what I'm saying when I'm saying without a calculator, you're going to be able to use something on your list. When you see things like this, remember what we talked about, that this 2 on the bottom is the same as the square root of 9. That's where the 2 is, and then to the third. And so this is a 2-step process to do this. You can do it in either order that you want, but sometimes one order is easier than the other. I think it's easiest to take the square root of 9 first. What is the square root of 9? That one you probably don't need to look at the list. What do you think, Sophia? Square root of 9? 3. Okay, so I'm going to rewrite this as 3 to the third, and 3 to the third is 27. Okay. For this one, and by the way, if you prefer and you want to write it as like, I'll show it in a different color. If you want to write it like as this, because you like that better than the square root, it's the same idea. You're just separating that power. Those mean the same thing. Okay, next one. What does the negative mean again? 1 over. Okay, so I'm going to do 1 over, and then I'm going to use my rule. This bottom number is the root. So this is the 5th root of 32 squared. Let's go back and look at our list. Or you can maybe know what it is in your head. What is the 5th root of 32? So I go to my 5th roots. The 5th root of 32 is 2. Think about that. 2 times 2 times 2 times 2. Did I say enough of them? 2 to the 5th is 32. So the 5th root is a 2. So this is the same as 1 over 2 squared, or 1/4. So let's make the distinction between that's what you do when it's a negative exponent. A negative exponent means 1 over. This time, is the negative in the exponent? No. That just means that my answer, because it's a 5th root, is going to be a negative number. So what's the 5th root of 32? 2. So what do you think the 5th root of negative 32 is? What do you think? Negative 2. If you don't understand why, I'll show you why. Negative 2 times negative 2, I'm going to multiply it out. The 2 times 2 times 2 times 2 part gives me the 32. But hopefully we know a negative times a negative is a positive. So it's positive now. Now it's negative. Now it's positive. Now it's negative again. Odd roots can be negative. Even roots can't, because it's impossible to make an even amount of negatives be positive. All right, D. This is a negative exponent again. What are we going to do? 1 over. What root is it? Cubed root of 64 squared. Okay. look at our cubed roots. The cubed root of 64 is 4. Okay, we're looking at cubed root. Cubed root of 64 is 4. So that's my first simplification. And then I'm going to square it. And what's 4 squared? 16. Okay, would you try letter E? So we have the 4th root of 16 squared. All right, so hopefully you made that simplification. 4th root of 16 is 2. 2 squared equals 4. Okay. So I have us do some negative exponents here. And when we did negative exponents, we did 1 over. Because the negative exponent means reciprocal. Okay, that's why. Well, what if it's written like this? What is the reciprocal of 1 over 64? What do you think I would do for that? What's that? Yeah, you just flip it over, right? So if I said, because really, if I said, what's the reciprocal of 64? That's 64 over 1. You flip it to make 1 over 64, and you're exactly right. If I wanted to do the reciprocal of this, I would flip it as 64 over 1. So this is the same as 64 to the 2/3. I take my root. This is the cubed root of 64 squared. We did something similar earlier on. The cubed root of 64 is 4. And 4 squared is 16. Okay. I'm going to just give you a disclaimer in example 7. I will never ask you, I'm going to show you it. I'll never ask you as complex as A. I would ask you B, okay? And something like C, I might ask with one of the radicals, but not as the other. I would say to you, hey, you should know how to do that up there. You should know how to write a radical with a root and a power. But two of them's a little bit more complex, but I'm going to show you how to do it, okay? Understanding that we should know how to do this. So we're trying to simplify these are radicals. I want them to be fractions. That's all that means. I want them to be fraction powers. Okay, so here's what we do when there's multiples. Start on the inside. What's on the most inside of this expression? And it is 64x to the 6. Would you put a parentheses around? That's how we're going to start. Then we're going to move out. What does this mean right here? Cubed root. The cubed root, to change it to an exponent, means I'm going to raise that to the 1/3 power. So that's coming from right here. All right, so we have, notice we have the inside. Now I have this one. Now let's do the outerst one. It's a square root, okay? So the square root power, excuse me, I'm going to do another set of parentheses, and I'm going to raise it to the 1/2. Okay, I'm then going to put that together. Let's do numerator. 6 times 1 times 1 is what? Yeah, if I wanted to, I could do both of those things as rational expressions. So for this one, 6 times 1 times 1 is 6, and isn't 3 over 2 also 6? So what's 6 over 6 simplify to be? just 1. If I was simplifying the x to the 6th part, it simplifies to x to the 1st. If I was doing 64 to the 1/3 to the 1/2, there's no 6th power there. That would be 64 to the 1/6. Would you do a quick check for me? Is the 6th root of 64 on our list? What is the 6th root of 64? 2. That's pretty difficult. All right, what if I just have one of these? Okay, we can do this. How would I write this? This is x to the what? Squared over 3. And finally, C says, use the properties of exponent to determine the value of y. All I'm asking for is, what is the exponent here? Let's try this again. We have our x to the 5th. This first one's a cubed root, so that's to the 1/3. And the second one is a square root, that's to the 1/2. Let's put our exponents together. That's x to the 5 over 6. So the question is, what is y? Y would just be 5 over 6. Okay.